Hello and good morning dear students. So welcome back to the online class again. Today is 9th of March 2021. Okay. So in the last class we were doing exercise 2b and we have completed till question number 11. Okay. So in today's class we'll do from question number 12. The question is to prove that using the laws of indices. Okay, the question is x to the power a divided by x to the power b and whole to the power 1 by ab. Okay, ab whole to the power 1 by ab. Similarly, bc whole to the power 1 by bc and ca whole to the power 1 by ca. Alright, so all these expressions within the first bracket, first we'll use the which law? Quotient law. We'll use the quotient law. The bases are same. So this will be x to the power a minus b, x to the power b minus c and x to the power c minus a. Clear till here? And then put the powers 1 by ab, 1 by bc, 1 by ca. Okay, so till here. And after that, the second line, what we can do is we can use the power law. The first line is because of the quotient law and the second line will be of power law. Okay, so in the power law you can multiply the powers, you know, so just multiply the powers. Okay, I'm keeping this within the bracket. So a minus b divided by 1 by ab, b minus c divided by bc and c minus a divided by multiplied by 1 by ca. Okay, so now you can multiply the powers. So if I multiply the powers, this will be ab by ab, b minus c by bc and c minus a divided by ca. Now, as the bases are same, and in between there is a multiplication sign, alright, so we can use the product law. So the product law means now we can add the powers. So keep your base as x and let us add the powers. So on addition we get a minus b divided by ab plus b minus c divided by bc and plus c minus a divided by ca. Clear till here? Now x, keep it as x, and right at the top now we'll take the LCM. If you see properly out here, the LCM will be LCM of AB, BC and CA. The LCM will be ABC. Okay, so this is your x to the power ABC. Now how we to take the LCM? AB into which number is ABC? AB into C. So therefore with C we have to multiply a minus b. So hence the first number out here will be c bracket a minus b plus bc into a. So a into b minus c and then ca plus ca into b, right? So b into c minus a. So once you do that, from here we get, now I can multiply and open the brackets. So keep your x as it is. On the numerator, c multiplies with a and b, so ac minus bc. Okay, plus again multiply with a, this becomes your ab minus ac. Alright, and then plus again multiply with b, this becomes bc minus ab. Okay, and whole divided by ABC. You need to write this right at the top. So make your x as much as you can big. Okay, so write this is x. Alright, now what gets cancelled out here? Let us see. This plus AC and minus AC gets cancelled out. Alright, minus BC and plus BC gets cancelled out, and plus AB and minus AB also gets cancelled out. So therefore we get x to the power, everything gets cancelled out. So this is 0 divided by ABC. Alright, 0 divided by ABC. And we know that whenever we divide 0 by any number, the value is always 0. So hence we are left with x to the power 0. So x to the power 0, we know it is 1. That's what we have to prove out here. So hence you can write down, therefore LHS is equals to RHS. Okay, proved. Right, so pause the video and note it down. Alright, let's proceed with the next sum. And the next sum out here is question number 12 part 2. So in question number 12 part 2, the question says 1 divided by 1 plus x to the power a minus b plus 1 divided by 1 plus x to the power b minus a. So now what happens out here? 1 and 1 keep it as it is. 1 and 1 also keep it as it is. But x to the power a minus b, we know that x to the power a minus b is x to the power a divided by x to the power b, isn't it? By quotient law. This is by quotient law. Okay, by quotient law we get this. So hence x to the power a minus b I can write as x to the power a by x to the power b. Similarly, x to the power b minus a I can write as x to the power b by x to the power a. Alright, line by line. And now here in the denominator we can take the LCM x to the power b. Here we can take the LCM as x to the power a. Once you take the LCM, we get x to the power b plus x to the power a and x to the power a plus x to the power b. Alright, now we know whenever I am dividing a fraction by fraction, it becomes reciprocal. This denominator goes in the numerator and this also goes in the numerator. So hence we get back x to the power a divided by x to the power b plus x to the power a. I can write as x to the power a plus x to the power b, plus similarly this is x to the power a, it goes up in the numerator, right, divided by x to the power a plus x to the power b. And now we can see out here what is the LCM. The LCM is x to the power a plus x to the power b. So hence I'll do it out here. The LCM out here is x to the power a plus x to the power b. This is the LCM. So this into 1, so 1 into x to the power a, x to the power a, plus this into 1 into x to the power, sorry, this is b, okay, this is b and x to the power a. So these two are same, isn't it? So it gets cancelled out, so hence I get the answer as 1. So hence LHS equals to RHS is equals to RHS, and it is proved. Okay, so if you don't understand, please pause the video again, rewind it, and then copy, note it down. Alright, let's proceed with another sum, and that is question number 13 part 1. In question number 13 part 1, the question says find the value of n. Find the value of n when this is equals to this. Alright, now you can see the bases are 12, 12, 12 and 12. So on the left hand side, 12 to the power minus 5 into 12 to the power 2n plus 1. So what we know, when the bases are same, and if in between there is multiplication sign, we can always add the powers. So minus 5 plus 2n plus 1 is equals to, use the quotient law, 13 minus 7. Alright, so minus 5 plus 2n plus 1, which is equals to 13 minus 7 is 6. Okay, so hence minus 5 plus 1 is minus 4. So 2n minus 4 is equals to 12 to the power 6. I hope you are clear till here. Please pause the video, note it down and understand. Right? Okay, now as the bases are same, you can write down as the bases are same. Remember that, boys, always if the bases are same on both the sides, then we can always equate the powers. So this power is always equals to this. So therefore this implies as the bases are same, we can equate the powers. Okay, we can equate the powers, which will give me 2n minus 4, which is equals to 6. So therefore 2n is equals to 6 plus 4. So therefore 2n is equals to 10. So hence n is equals to 10 by 2, which will give me n equals to 5. So hence please note down the answer as n equals to 5. So please pause the video and note it down. Alright, dear students, so let's move on to the last question for today and the last question from this chapter as well. Again, the question says simplify, number 14 part 2. Again, first you see the base, x, x and x everywhere. Okay, so in the numerator there are 2x, so I can add the powers. Okay, so quickly, x to the power 2n plus 7 into x to the power, you can multiply through 2 3s are 6, 2 2s are 4. Clear? Divided by denominator 4 2s are 8, 4 3s are 12. Okay, I hope you are clear till here, the first two lines. From here to here, what I have done is x to the power this into x to the power this. When the bases are same, and in between there is multiplication sign, I can always add the powers. So add the powers means 2n plus 7 plus 6n plus 4 whole divided by x to the power 8n plus 12. Okay, I've used the power product law, and now which will give me 2n plus 6n, 2 plus 6, 8 plus 7 plus 4, 11 divided by 8x to the power 8n plus 12 is as it is. Okay, till here. Now what will I do? I'll take this term to the numerator and the powers will be negative, minus 8n minus 12. So hence I get x to the power 8n plus 11 minus 8n and minus 12. Okay, so what happens out here? Plus 8n and minus 8n gets cancelled out. So I'm left with x to the power 11 minus 12. So what is 11 minus 12? Minus 1. That is x to the power minus 1, which equals to 1 by x. So this is your answer. Okay, so I hope you're clear till here. This completes the exercise as well as this chapter. Today's assignment will be to do, homework will be question number 13 part 2, question 13 number part 2 and question number 14 part 1. So these two assignments I'm giving today, and we are closing the chapter with this. Okay, so complete this, complete the assignments as well and send it to me by tomorrow. So that's it for today, and tomorrow we will start a new chapter. Okay, thank you, take care, and bye bye.